Mentally math!
Let's get mental!
Alright.
You sounded sleepy.
Yeah.
You do sound a little sleepy, but that's okay.
Sleepy.
Definitely remind me to bring Mr. Squeege out here when we're done so you can take a look at where he's at. Not growing as fast as the first one, as that first flush. That first flush was crazy. So it's growing slower, but it's also pretty amazing that it's growing at all.
I think it used up so much energy with that.
It seems like it, yeah. And it's been acting really unusually for a while. Okay, so I'm sure that this gives you a chance to get out ahead of me. So looking at this, there's several different ways I could look at this really. I think I'm going to look at it the same way I looked as the example they gave yesterday is I can change this to 1 8/10 times 100. 8/10 and boingy boingy.
How convenient for C, X in Roman numerals, or you can post time.
Okay, fascinating. Alright, then B is just 7 5/10 times 100. 750. Edgy. Alright, feeling edgy. Then, yeah, 35 plus 5 is 40, divided by 10, or divided by 4, excuse me, is 10. And that one's
Edgy.
also, I'm feeling very edgy today, apparently.
How convenient X equals 10.
Yeah, you mentioned that. Yeah. Coincidence. Or is it?
Yeah.
Alright, then converting 20 centimeters to millimeters would be metric conversion. Easy peasy, lemon squeezy. So we would just multiply that times 10.
Easy for metric conversion.
Yeah, I know. I said the E word, but it's pretty. Yeah, I've tried to come up with a rhyme involving simple, and the only thing I can think of is dimple, and it doesn't work. Okay, anyway, moving right along. This is really just square root of 25 is just 5. Then looking. Hold on, we have a bit of chatter in here. What's up?
At first I thought you had to square root 9 and 16 and then add them up. But later I figured that you could add them.
No, you can almost consider this kind of like an inclusion symbol of inclusion. You do these guys first. Okay, then 1/9 would be 20 cents. So 20 times 5 is $1. Then the name for a regular triangle would be, whoa boy, all those sides are equal. What do we call this? An equilateral. Now remember, it's an equilateral, not an equilateral. It's got an I. Equil.
No explanation, that is disappointing. Is it UI or IU?
Yeah, what does it?
UI or IU? It's
I'm just writing it's UI.
equilateral.
There's no estimation, that just so disappointing.
Okay, so meanwhile, down at the bottom of the page, we could say 2 5/10 times 2 is 5, plus 3 is 8, divided by 4 is 2, minus 1 5/10 is
Barely holding on.
500. Okay.
500?
Tenths. Okay, maybe I'm sleepy too. Okay, so today's lesson, I guess we'll go back to here, is adding positive and negative numbers. I think this is pretty reviewy.
Wait, really adding
I think, yeah.
Literally, is there pressure?
So I'm gonna just show some of these using a number line. You don't really need to do that. I have one of these examples I would like you to do a Saxon number line with, but I'm just going to be kind of fiddling around with number lines just to sort of let you see what's going on with these numbers. Yes.
So if they don't tell us to use a number line for the problems, can we just do it without?
Oh, absolutely. Yeah. If they don't say to use a number line, you don't have to. I try to keep to, you are bound to the instructions that you are given in general. Yes.
I'm kind of lucky because on Monday I was actually learning with my mom, so.
Oh, right on. Okay, so well, before we start, let's talk about our friend the plus sign. Yeah. So what an addition sign means is combine these values together. That's really what it means.
Oh, we actually learned this in physics.
Yes, but it's good to point this out because we are combining positive and negative values. So what you did in kindergarten was 1 plus 1, adding the value, combining the value of 1 with the value of 1 to get 2. However, it's like what happens if you're doing 2 plus, and say we're combining the value of positive 2 plus negative 1. That's what today's lesson is about.
For positive, remember, don't you just write the number and start putting the...
Well, as you see, that's not the way they're doing it for this. So yes, in general, we would, if there's not a positive or a negative value that has been assigned to a number, we assume that it is a positive number, and that unless it has a negative sign, we just assume it's positive. But for clarity, I think they're trying to be really clear that we're combining positive and negative values together and what that means. So that's, I believe, what the parentheses and having an actual positive sign in front of a positive value, even though it is a bit redundant. Yes. I think they're just striving for clarity here. So, if we're thinking in terms of the number line, so for A, you can think of it maybe like this is, so, we do start at 0, and then our first value is negative 54. So that sends us to the left of the number line, and we end up at negative 54 on the number line. But then we are combining that with the value of negative 78, which essentially means we are going 78 more to the left. So that essentially means that to figure out where you wound up over here, you're going to need to combine these values. And in this case, since they're both negative numbers, you can just add them together. Yeah.
The previous example in the last one?
Yeah, this is a bit reviewy, if that's what you're getting at. Okay, so then we can just add these together to get, and then you would end up with negative 132. There, I'm just yeah, that guy over there. So that's kind of what we're doing with combining two negative values. But for our next example, we have a positive and a negative value that we're combining. So you can think that we are still starting at the 0, but in this case,
couldn't you just subtract 67 from 45 and put the negative sign?
yes, and that is ultimately what I'm going to do. Yep. So, but I'm just kind of trying to show what we're doing. But yeah, you're absolutely correct. That is how we will find the difference and slap a negative sign on it. So our first jump was 45 units to the right. So that's where we landed over here. But yeah, we are going to do an about face and head back. See if I can draw close enough to a straight line for it to try to figure out what I'm doing. Fine.
Yeah.
I think I overshot a little bit though. Okay, and so now we are combining that with a value of negative 67. And yeah, you're absolutely correct. So at this point we can kind of treat this as a subtraction problem, because to figure out where we are here, we need to know what is the difference between 45 and 67 to figure out what we have left over. What's a nice color here? Red. Oh, I didn't even do it. Okay, so to figure out where that is, yeah, we would subtract these. So I'm just gonna use these up here to work with. Okay, so then that would be -2 and then -2. So that would get us, this would have to be at negative 22 on the number line. Okay, and then this last one, well, I mean, you can look at it.
0.
And yeah, well, if you're combining an equal negative and positive value, then yes, you can only end up with 0. I mean, how this would end up looking like would be, okay, we're starting at 0. Fine. This is my last try no matter what. Okay, fine. With this nice curvy line over here, so you end up at negative 92, going minus 92, and then you do an about face, and plus 92. It just lands you right back at 0. Okay, good talk. All right, so please draw your own crazy Saxon number line for this one.
I already did it.
Okay, cool. All right. Yes, you must do a number line for this one right now, or you will go to math jail.
That's not.
Hey, you know what though? The last class complained so much, I gave them 2 focus points for doing it. I'll do the same for you.
Money?
Focus points, not. There's 2 focus points for your focus and effort.
I don't know why you don't like these problems. They're so fun.
Right, okay, that's what I thought. I thought I was like the only one excited about crazy Saxon number lines today. I mean, I was really excited. I was like out in the parking lot, at the cars this morning, going, "Guess what, guys? We're doing crazy Saxon number lines today." And everyone's like, "What? Whatever." Huh?
So this problem's it's really fun. I mean, it's simple to see if you do it in your head.
Sure.
It's really simple.
And it's totally doable in your head.
Yeah.
But I just want to like do a little illustration of what is going on with the actual values. Okay. So that should give you plenty of time to get out ahead of me. Especially with how many of these straight lines I'm needing to redo lately. Okay, I need to make these kind of squad. Okay, so we always start at 0. And then our first value is to go 3 units to the left, because our value is -3. But then we are adding a value of -2. Color.
Will this be on the test?
Something like this, but I doubt you will need to draw a number line. Okay,
I like
and
the
then
number line, but it just takes a lot to work.
okay. So then we are combining a value of -2, getting us to -5 on the number line. But now we are combining that with a value of +7. Which is going to take us all the way back. Oops.
We're going all the way.
I think I need to clean my iPad. All the way back up here, so +7. And then let me make this one purple. But then we are doing another about face, which I tried going this way last time and the class got angry at me. So because they're like, you always go up, Mr. Petrie.
Yes.
Okay, fine. I'm going up. Alright, then going another -4. Whoops, no. You see, now I'm grabbing onto my thing there. It's just okay. Great.
Technology.
Technology's great when it works. Okay, here we go. That's my motto.
Technology is great when it works.
When it works, yes. That's one of my catchphrases. Alright. So then that was another -4. Which gets us to a final resting spot of -2 on the number line.
We traveled a long way.
And yeah, oh, we traveled back and forth, up and down, left and right,
Across oceans.
uh-huh,
Across oceans.
into and out of the negative zone, then back in. Dramatic echo. Okay, so enough number lines. But now we need to take a look at what we're doing with something like this. So now this isn't too tricky because if we're combining two negative values. So of course that means we're just gonna keep on going that way until we get to the finish line. And what this essentially means, now you can think of this as we are going to combine the absolute values of each of these numbers and slap a negative sign on it.
Mr. Petrie?
So you can think of it as, ooh, what do these vertical bars mean?
What are those parentheses?
Well, what do the parentheses mean? Well, the parentheses, they're using the parentheses to kind of shield it off so that they can then say positive or negative for the value. That's the only purpose of the parentheses.
Just to say that it's negative?
Yeah, and so you can think of it like we're taking the absolute value of each of these, combining it, and then, well, slapping a negative sign on it. Just slapping that on there. So I'm going to do my conversion ahead of time here. I'm going to need to use 6 for the common denominator. 3 and 2, 6. And so I just combine the values, the absolute values. But I know I'm combining negative values, so I need to slap a negative sign on it. Ta-da! Now, so that's pretty straightforward. Now with B, you might want to remember what happened last time or back here with example B was essentially we needed to find out what the difference between the values was so that we could figure out where in the negative zone we were. And so it's the same sort of thing of we can see that the value of the negative number is higher than the positive number. So we know we're going to end up with a negative number, but now we just need to know what the difference is. So we, once again, just combine the absolute value of each one. So you can imagine that these have the vertical bars, which means absolute value, which means you ignore the negative sign. Please do not forget that rule. It's a simple rule. Yes. At least something testing whether or not you know what absolute value means and what those vertical bars mean. It absolutely will be on the CTP. Okay, so I'm subtracting these. Can add a little placeholder. 0 here. Or do a little regrouping. I'm assuming you're already done. If you're not,
Yeah.
okay, all right. I know I'm moving along pretty slowly here. Okay, so bring that over there. Okay. All right, so am I done?
No. Remember that negative sign.
Yes. And put.
Oh, gee.
It's all right. Okay, so yeah, that's how we would get that. And finally, let's see if you can figure this out before I put it up there. So, on one stock trade, Mr. Figuera lost $450. He's in the red, as it were.
Yeah.
But on his second trade, he gained $800. So what was the, here's this term again, net result. The net result. So net result, of course, means that once we've done all our calculations, what do we have left? That's basically what net result is. One way we can think of it is like, say, an example, say with taxes, is if I make $60,000 a year, but I pay $20,000 in taxes, what is my net income?
40,000.
40,000. So that's what we mean by net result. Of what do we end up with?
Yeah, like when you're in a company and you have to pay everyone that you bought and pay sales tax and everything before getting your actual income.
Yeah, that sort of thing. But anyway, we're talking about Mr. Figuera and his stocks. Okay, so I'm going to give you a moment to try to figure this out first before I demonstrate. It's pretty simple, really, based on what we've already learned. Is we are going to end up going negative 450 from our 0 on our number line, but then we're going to end up going back. No, you do not need to do a number line. We're going to end up going back 800. So the question is, what do we have left over up here? Or another way we could think of that is, what's the difference between these two numbers? Which we can think of as, well, let's subtract these numbers. It's literally called the difference is the answer to it. Okay, and spoilers, that will end up being $350. So his net result was he gained.
I just put plus.
Sure, you could say that. $350 gained.
Yeah,
All right.
My number line.
Huh?
I'm drawing a number line.
Oh, good for you. Right on. Okay, so that's today's lesson.